Okay, let's take a look at this problem. It says, how many positive integers less than 1,000 are multiples of 3, 5, or 7? Explain your answer using the principle of inclusion, exclusion. Okay, so up to our set of numbers is positive integers, so less 1 to 1,000, and multiples of 3, 5, or 7. Okay, so for 3, I'm going to say that's T for 3. And 5, F for 5, and S for 7. Now, in the previous problem, I talked about how to derive this, so I won't go over that again. Our total number is going to be the cardinality of T, the number of 3s, plus cardinality of F, number of 5s, plus cardinality of S, the number of 7s, minus the cardinality of the intersection of T and F, minus the cardinality of the intersection of T and S, minus the cardinality of F and S, plus, and then the cardinality of T and F and S. Now this is goes back to the cardinality of a union with 3 sets, but these are what we're going to find. Okay, so the 3. To find its cardinality, what you do is you take your total number, which is 1,000, and you divide by 3, and you drop off any decimals you have. So 1,000 divided by 3 gives us 333. So the cardinality of 3 is going to equal to 333. Now I dropped off the decimals. Okay, 5. Take 1,000 divided by 5. I might be able to do that in my head. 200. So the cardinality of F is 200. 7. I'll take 1,000 divided by 7 is 142, dropping off the decimals. So the cardinality of S is going to equal to 142. Now the next one, I'm just going down the list here, T, F, and S. The next one's T and F. Now T is 3 and F is 5. So what we do is we take 3 times 5, which gives us 15. And then we do the same thing. Take 1,000 divided by 15, and we'll drop off any decimals. That gives us 66. So the cardinality of, what was this one? This was T and, why did I put 15 there? That's 3 times 5. Okay. This is cardinality of T and F is equal to 66. Now my next one is T, which is 3, and S, which is 7, 3 times 7. That gives us 21. And then we do the same thing. We take 1,000 divided by 21. In the previous problem, I show why this works. So I won't explore that here. I want to explore something else, actually. So 47. So the cardinality of T and S is equal to 47. Okay. Now we need F, which is 5, times S, which is 7. That's this one right here. It gives us 35. Same principle. Take 1,000 divided by 35. That gives us 28. So the cardinality of F and S is going to equal 28. And one last one. This piece right here, the plus that T is 3 times F is 5 times S is 7. I think 105, but let me see. 15 times 7, 105. So then I take 1,000 divided by 105. That gives us 9. So cardinality of F and what's 3. Let's try it again. 3 and 5 and S. That's gonna be 9. Now I'm going back to this formula right here. So now I'm going to plug in my numbers to that. So I'm going to have 333 plus 200 plus 142 minus 66 minus 47 minus 28 plus 9. 333 plus 200 plus 142 minus 66 minus 47 minus 28 plus 9. I get 543. Now I'm gonna write a computer program to show this. Many of you are computer science majors, if not all, so I thought that might be kind of fun for a problem. Okay, I'm gonna do in Visual Studio using C#. So I'll create a new project and Windows format C#. Next, visibility by 3, 4, 3, 4. Where did that come from? 357, I think it was. Okay. Nothing too exciting on here. I'm just going to have a button and then my answer. So I go to Toolbox here. I'll drop on a button. And I'll drop on a text box. I won't put much effort into making this look good or anything. What am I doing that for? All. It's weird. I don't remember expanding that all, but maybe I clicked it just now. Okay, I'll make that a little bigger so you can see it. And there we go. Give this a name so I can refer to it programming wise. So TB underscore answer, TB for text box. And I'll change this one to say calculate. Okay, so I'm going to double click that. And I'm going to declare my answer as an integer. And I'm going to have a loop here for int x equals 1. And I'm going to continue while x is less than or equal to 1,000, and then x plus plus. Okay. And I'm gonna really use a lot of variables here. I don't necessarily need to use all these, but okay. So I'm looking at the cardinality. So let's say card of 5, card of 3, card of. Actually, I guess I can actually put the numbers there. That might be easier to program. Cardinality of 5, cardinality of 3, cardinality of 7. Okay, so let's put that in there first. I need to initialize these. So card 3 is equal to 0. Card 5 is equal to 0. Card 7 is equal to 0. Now here, I'm going to say, this is comments, check if divisible, or yeah. Okay, let me think this through. Yeah, that's going the other direction. Check for divisibility. Check for divisibility by 3. So if x, so we had to mix this up with another language, percent 3 equals 0, then card 3, and I can do plus plus, but I'll do card 3 plus 1. I'm increasing it by 1. If x 5 equals 0, card 5, I could again do plus plus, but you may wonder why'd you just do that? I find people learning programming for the first time, it's better to not use that to begin with. Card 7 equals card 7, not that some of you aren't just learning it. Okay, so then down here, my answer is going to equal to card 3 plus card 5 plus card 7. And I want to write it out. I put it in the text box. Was this two string or just string dot value? I think it's two string. I teach various programming languages, so I get them mixed up. So let's run that. Calculate. 675. 675. Um, 5, 3. Let me see. 3, 4, 5. Okay, 675. Okay, so that checks. So that's this first part here, the cardinality of T, F, and S. Now we're going to look at the intersection of those. Specifically, we're checking to see if it's divisible by 15, 21, and 35. So cardinality of 3 and 5 is equal to 0. Cardinality of 3 and 7 equal to 0. Cardinality of 5 and 7 is equal to 0. So better declare them. Card underscore 3, 5, card underscore 3, 7, card underscore 5, 7. And while I'm here, I'll go ahead and put the last one. 3, 5, 7. Initialize that. 7 equals 0. Okay, so down here then, I'm going to check if x is divisible by 3 times 5. Equals 0. Then we're going to have card 3, 5 equals card 3, 5 plus 1. And just make my life a little bit easier, Control C, Control V, and I'm going to put the last one on there too. Okay, so 3, 5, next one would be 3, 7. Let's say 3, 7. Watch me screw this up by doing this. Boy, I'm going to mess it up. 3, 5, 3, 5, 3, 7. That should be 7 there. 3, 7, 3, 7. This would be 5 and 7. Hopefully you're enjoying the programming. If you're a programmer type, you can see how you can check your work. Okay, and last one was 3 and 5 and 7. So 3, 5, and 7, 3, 5, and 7. So then here, principle of inclusion, exclusion. Our cardinality of a union 3 sets says we need to subtract our intersections now. And I'll do this on a separate line just so it doesn't scroll off to the side. Answers equal to answer minus card 3, 5 minus card 3, 7 minus card 5, 7. What doesn't it like about that? Okay. And then I want to add back on the intersection of all 3. So card 3, 5, 7. Okay. Let me run that. Truth is, whether it works or not. 543. 543. Okay. Anyway, that was my first thought actually when I ran across these problems. Like, well, I'll just write a program for that. It's like, no, they're supposed to use the principles of that section for it.